All right. So for students specifically in business calculus course, now I am very sure that prior to entering this course right here, business calculus course, you must have gone through some kind of finite mathematics course for business math major, mainly the algebra work that's being used for business application. However, in my teaching experience, I see that a lot of times when students before business calculus, when they're still taking their students are still taking their finite business math courses, then usually since they're maybe not very sure whether how far they're going in their career. I mean, in their track for heading out to a business career. So, at the time when they're still taking the finite business math course prior to business calculus, they don't feel how important the concepts they've learned there. And not until the time when they arrive, the students in business math arrive at business calculus courses, then, all of a sudden they feel how important the skills they've learned back in finite math courses to be brought over and used at a business calculus math course. And so in that way, I designed this video lecture. My main aim here is I would like to, even though this is a calculus course for business math major, but I would like to bring back quite a few old skills. So it's sort of like I'm going to make a connection between the skill we learned here in calculus and how it's all connected together with the skills you have learned back in your finite math course right there, where back at that time you might feel unsure how useful those skills could be for you. But now let's make that clear connection. And so in the plan for this lecture here is that I'm going to design one example throughout the entire lecture here, and I am going to go completely improvise. Meaning I did not plan the example at all, but instead I only think of the situation here is we only treat the problem as some written description for us, and then we're gonna extracting information one by one and on the go we're gonna create different kinds of functions that involves revenues, cost, profits, and any of those quantities that you have learned since your finite math courses. And we're gonna still be using those and build more the good usefulness of those functions in our particularly business calculus course here. Okay, so now before I head out to the actual example, I just need to remind, and as I said again, I am very sure that anyone who is taking calculus currently must have gone through a finite math course for business, and so you must be familiar with these quantities again. So anytime you're opening a business or leading a new business or leading a business, the first thing to consider, the first quantity to consider is the cost. And so traditionally we use a capital letter C here to represent cost, and usually we use the variable x here to be, but I'm only saying usually. So x is usually, in this case, the quantity. Okay. The quantity, or to be precise, the number of units to be produced here. Okay, because that's the first thing we have to spend on our own expenses out of pocket. That's cost right there to produce, to make our production. Okay, to make our products, and then after that we are going to sell away, and so along the way. And so as I said, usually or most of the time, the main variable of the cost function can be regarded as where x here, the variable is the number of units being produced right here. But there are other times, and we will get to that as well. But then after that, there is along the way, before you can sell, then there's there's a relationship between price. There's price and there's price that you need to decide. Okay, price to be decided. And then once you decided a price, and usually it's a lowercase letter p right there. And then once you decided a price, then we are selling your product away. And that comes revenue, which is the second big step after cost right there. And revenue is usually, no, I should not say usually anymore, but fundamentally, revenue is always equals to the price that you have decided per item and multiply with quantity. And quantity here is the x, that how much of the quantity that you are selling away. Okay, and so price times quantity, and that's your revenue. And so namely it's P times X. That's the revenue. That's the most fundamental relationship between how revenue is related with price that you decided and the quantity as the X variable. And then after you've sold your product away and made some revenue, then we're looking at the final stage here is making your own earning, and this is where we call the profits, and that is the revenue subtract away the cost, and that leaves us, and what's left behind, what remains, that's the profits that we are working with. I mean that we're earning for our own enjoyment. Okay. And that's for you to decide whether you should continue with your business further. And so if profit is a function of X and revenue, if we can run that as a function of X as well, where X is a quantity and cost is a quantity, then that's mathematically how it's written. Okay, but so that's just the big picture when we put it together. Okay, that's just the big picture. And then I need to also emphasize here. Now, back to the step here, after you spend your own cost right here to make quantity, then and then when we moved on to deciding a price here, this is where demand and supply equations, the demand and supply relationships comes in this step right here, so that you can decide what is a good price, or that you can be selling at a good quantity. And that's the whole purpose why back in your finite business math course you're spending all that time learning how to at least derive some basic and spend time to understand the basic demand and supply equations right there. Okay, and so this is where we study about demand and supply. And once we're looking at the demand and supply, then we can and come up with a decided price, then that price right there is going to be multiplied with quantity so that we can find revenue and then move on to finding your profits, the profits for your function. Okay, so now let me actually bring up the example that I was planning to, that I was intending to show anyone. So again, keep in mind, this example is not a planned example. Think of that as like it's some information that I found over an article or over a newspaper, that it's sort of like a report from a company. And then we're gonna see if we can do the problem, we can bring out as much quantities as we can using all of our mathematical understandings. Okay, so here we go. So now there's a company. There's a real estate. Packham in Real Estate is building a new housing development. Okay, so here we're thinking about maybe we put ourselves in the situation where we own that business right there. The name of the business is Packham in Real Estate. Okay, and so we are building new housing development, and so this is the only information we know, and I will not give out any questions because, as I said, we are going on the go right here. We're gonna see what we can do with the information we have right here. let's work like a real expert here, like we're starting things from scratch. So let's read it a little bit. So our company with this name right here is building a new housing development. So the more houses it builds, the less people will be willing to pay, and because of the crowding and the smallest lot sizes. Okay, so that information can be used later. And in fact, if our company builds 40 houses in this particular development, then it can sell them for $200,000 for each house. But if it builds 50 houses in this same lot right here, then we will be able to get only $160,000 each house. And so, in my experience, I see this very last piece of information is actually useful. According to their reports, the company's reports, okay? Think about they can hire the professionals to analyze the what kind of cost they have to spend first, because that's what it is. Anytime that we open a new business, cost is the first factor that we're looking for. And that's why, even though I show the whole problem, but what I would look for first is to look for what's costing our company to build these houses in that development site right there. And so this is the information that is going to catch my attention first, according to their report. So basically the company's report. Maybe I'm pretending myself here to be that analyst who's doing the math for the company. So according to their reports, materials cost them $120,000 per house. Okay, so that's one cost right there. Okay, materials cost them $120,000 per house. And the development lot cost them $1,500,000 or $1.5 million. So right from there, we don't have to read anywhere else further, but right from that highlighted information that I have just shown right there, we can now start tracing down our cost. So think about if your job is being hired as a professional who analyzes the cost for a company. Maybe because the business owner is too busy. They don't have time to lay down all these math right here. They hire us. They hire you to do these math for them. Then with that information I highlighted earlier, we can do a lot of useful information for the one who is hiring us already. And now as I go through with this problem, you will see how valuable that you have already learned through your finite math course for business before business calculus here. So if you recall from finite math course for business, then any cost in a deeper understanding, any cost is involved will be involving variable cost. And we have to consider, so we always have two different costs to consider together. So the variable cost and the fixed cost. Okay, variable cost is the kind of cost generally, anyone at this class that you are learning, you must understand that variable cost is the kind of cost where it depends on the quantity. Okay, the quantity. So in this case right here, what's our quantity? How many houses we can build? How many houses that real estate can build? Okay, and so let me quickly bring back the information right here. And so it looks like according to the two pieces of highlighted information here, then materials cost them $120,000 per house. Now maybe this information is too specific about materials, but it could have also already included labors and all that, because building a house, you also need to pay labors. You can't do that all by oneself. So think about that cost right there, $120,000 a house. Okay, it could already include the materials and labors and all that you have to spend specifically on each house, per house right there. And so what I'm saying now is that for cost, and so let's define the random variable, a variable x to be the number of houses, okay? The number of houses to be built. All right, so x here is the quantity, the number of houses to be built. And so in that case, variable cost allowed me to use just a shorthand writing VC right here. And please, if you're doing this problem on your own, you have your own choice of naming these as long as it makes sense, and we have a clear sense about documenting our work, every steps of our work. So variable cost in this case must be $120,000 per house. And as I said already, in the simplest, most ideal situation, it's already included all in one package, labor and materials for each house. Okay? Then $120,000 per house. Then we're planning to build X houses. Okay? Then it's going to be as far as variable cost, we're looking at 120,000 X. Okay? And so, what about the fixed cost? Allow me in this lecture to use FC right here to stand for fixed cost, but you can come up with your own name of the variable too. At this point, anyone learning in this video should be a lot more flexible than just getting your mind tied down to a variable's name. Okay? But so, in this case right here, all right, so that's the variable cost, and the development lot costs them $1.5 million. The development lot cost them $1.5 million. Okay, so that information, it seems too general. It seems a little bit too general, but think about that. Think about it a little bit. It could be, what does it mean by the development lot itself cost them? It could be, you got to buy the land. That's one fixed cost, and once you buy it, it's yours. And it doesn't depend on how many houses, because once you buy it, you build the houses on that. And plus, we probably have to also hire those professionals where they can help you decide, is that a good location so that your houses can be, good selling. Okay, and so it's all included in that, what I so-called the fixed cost, 1.5 million. Maybe the actual land size, the actual landscape there, the actual land there is not that expensive. Maybe just 900,000, but you have to spend another additional 600,000 to hire a professional. I'm just, making up a scenario right there. But all of that there is the fixed cost. And so the fixed cost there is 1.5 million. So, right, 6 figures. But that's the fixed cost. So now at least, if this is all the information, and supposedly in the ideal situation that there are no other hidden fees or hidden costs or anything like that, then we now can gladly say that we have a cost. So cost here, so this kind of work, anyone who has been through a finite math course for business prior to your business calculus, then you should have been trained with the skill. And so here I just purposely bring back those, but and as I said, there was no question in the example. It's just the information we have. This is what we can do with that. Okay, and put yourself in the position where you are an analyst, or you are that person who is analyzing for the business, or you are the business owner yourself and you want to do these math problems. And so the cost here is going to be 120,000 X. That's for variable cost portion summed up together with 1.5 million, which is 1,500,000. That's our cost right there. So now we have nailed down our cost. And so usually the way how it is when we're doing business, usually and most often cost is dependent on the quantity. Okay, because the reason, I mean, I'm not saying that it's all the time, but at least most often cost is derived as a function that's dependent on quantities. It makes sense that way, because if you're starting your business from scratch, then it depends on, the number of units you want to produce, right? And so that's how costs grow. Okay, and of course, I'm not talking about how we can find good cost to adjust our cost, but that's sort of like belong to the planning side of that. But it all still in the end dependent on the variable about how large the quantity of your production. Okay, so we got cost, and again, this is just now like what I meant earlier. I purposely bring back old concepts that that has been covered for you in your finite math course for business. Okay, so now we regain that skill how to derive a cost function. Okay, and so now I am going to swing back to the wording of the problem. So now we got cost, And so we spend our own money to build the houses, and then now we got to consider about selling it away. So these are now the factors that we need to read right here. Okay, so it makes sense that the more houses it built, that we built, if it's our company, then the more houses that we built, the less people will be willing to pay. It makes sense that way, because you see, in just a one same lot size that you bought for 1.5 million, but one same land size, and if you're trying to build too many houses, each house makes sense right there most directly. Each house gets smaller, so it gets less people's, less buyers' attraction. Okay, less people attracted to those houses that are being too small. Okay, but if you build too little number of houses, then there are other consequences, and that's why a lot of times, if you don't want to do these on your own, we are again hire professionals to observe the markets for us. And that's why, earlier when I was saying about we could be hiring a professional to decide for us whether it's a good location or not. All that cost here is being part of the fixed cost here. But so now suppose that professional has already observed the market for you, and now say, hey, if we built 40 houses in that particular development lot, then we can sell them for $200,000 each. Okay, so 40 houses in this particular location right here, we can sell at the price of $200,000 each. How do we know that? Yes, that's the whole point of hiring a professional. They observe markets for us if we don't want to be the person doing that ourselves. And then, but if our company builds 50 houses, then it will be, we can only sell for $160,000 for each house right there. Simple reason, as I have already explained. One of the most direct reason that I can answer is that because we build more houses, makes sense that our lots get smaller. I mean, the house size gets smaller. Okay, and so it gets less people's attraction. Okay, and so in that way, so that information right there is actually very useful for us to decide our demand and supply equation. Okay, so here's how the demand here specifically, the information here is for us to decide the demand as an equation right here. The demand, the relationship between pricing and quantity right there. All right, so now, and as I said, I did not plan the problem at all. I just read the information and show it live here how we can do it. And someone can do it, you can do it too. Okay, so let's say when pricing, see, 200,000 is the pricing. We can sell at, so lowercase p for pricing, we can sell at $200,000 per house. Okay, per house. Where when you're producing, when you build only 40 houses in that lot. So it's a pair of values between, so at that particular quantity, you can sell at this price per house. And then when you change, if you want to make more revenue, maybe make more quantity, okay, build more houses. But consequently, build more houses will make the house smaller. That's the first direct consequence. And so, but let's find out. If we increase, if we decide, so this part of this is also the planning process of your work as well, okay, in developing your own business out there. So if we want to change the quantity here, then we got to adjust and bring down the price, right? Or that's just the way it is. Even if we don't want to adjust, we have to bring it down to make customers happy. So $160,000 per house, okay? So that information. And so I don't want, of course, a lot of time in the finite business math courses that demand and supplies are mostly linear equation. Let's stay on that simple side right there. I'm not saying that outside of linear relationship, demand and supplies or cannot be any other forms of equation. Nope. But right here, assuming that we can just stay in a linear relationship, let's say assuming that even though the problem didn't even say that, but let's just stay with the simple case. Okay? It doesn't hurt because here I just only want to give a general picture of how the entire process works. Okay, and so if we are looking at the relationship, the relationship between price and quantity as a linear relationship, then how about for now, let's see how we can decide, because it looks like for now in my conversation with any of you, it looks like I'm trying to, I'm speaking in the point of view that changing the quantity affects the price of each house. And it's also the way how the worded problem is written that way. It's described that way. And so for that reason, allow me to write the linear relationship as P as a dependent variable, the price as the dependent variable, dependent on X as the quantity, but depending as a linear relationship. So what does that mean by being a linear relationship? Sum mx plus b. That's what a linear relationship is, where P is related to X by a linear setup like this. And m is the slope, X plus B right here, and P is the dependent variable, the price is the dependent variable, and it's dependent on the quantity. Okay, and as I have already explained my reason why I chose it this way right here, because it looks like so far we are in the situation where changing the quantity change the price right there, affects the price. Okay, and so in that way, how do we find slope? We can look back at these two lines of information right here, and we can see that we can treat, allow me to quickly put these together right here, but we can, so this is output value because that's the dependence variable, and that's input value according to this relationship that we're about to use. And so that means here we have a pair of value, 40, 200,000. And for this next line right here, it gives us actually another pair of value. 50 is the input because it's for X, it's the independent variable, and 160,000 is the output because it's the dependent variable's value. And so now we have another pair of value here being 50, $160,000. And so now with the two pairs of data right there, and now understanding our goal that we're about to find the relationship between price and quantity as a linear relationship, then now how do we find slope? Again, all that skills you've learned back in your algebra course or in your finite math course prior to calculus has equipped you with all the skill already. Slope is famously the change in output value, or change in y, rise over run or fall over run. So change in the output value. So final output value here is going to be, final output is 160,000 minus the initial output. So this is sort of like y2 minus y1 minus 200,000. Okay, and we're dividing by the change. So the final quantity here that we're looking for is 50, corresponding with, and subtracting that initial quantity is 40. So now we have a ratio, a ratio of two differences. Okay, and this is going to be our slope right there. And so now this is going to give me, that's minus 40,000 as the difference in the numerator, and divided by 10. And so now I know that my slope must be, the slope for my linear relationship between price and quantity has to be minus 4,000. And so now price, now we know a little further now, price can be determined based on or dependent on quantity by the following equation: minus 4,000 times whatever quantity that you're aiming at to produce, plus with some y-intercept, because any linear equation has to have a y-intercept value. Okay, and so we're about halfway of our price and quantity relationship, or this is the demand equation right there. Okay, And so to find B, it's now quite an easy solution. We can just simply pick one of the two pair of values, okay, and then just substitute it in X for X, P for P. Okay? And so I can just easily pick the first pair right here, even though anyone can also pick the other pair of values. And so 200,000. At that price, 200,000, then with slope minus 4,000. Correspondingly, X value there is the quantity, the number of houses there is 40 houses. Okay, plus B. And now it just, again, believe me, when you are here at a calculus course, math course, your mathematical mind is mature enough to quickly solve this problem. So now we can find out that B equals what? Okay, so 40 times 4,000, well, negative 4,000, right? And then all that here will be a negative. We're going to add to the other side right there. So altogether, we're looking at B should be equals to, okay, and that now gives me 1.8 millions. Okay, now allow me to kind of just get that calculation done on the calculator ahead of time a little bit, but that was not really what I was it's not a part of the plan work. It's just, I need some calculator to help me with my calculation. That's all. All right. But now at the end, at this point here, what we have had now is that we have completed our demand equation. Our demand equation here is, so now all of these extra information we can now, or how about let me swing back to my other board right there. All right, so now on this beginning board, on my first other board right there, then now I can recall that we already found the cost function. And now we further found, before we selling our houses away, we found that our price can be determined as in the following relationship with the quantity, with the number of houses that we're selling. So let's say it's minus 4,000 X plus 1.8 millions. That's our linear relationship as our demand equation. It points out a relationship between price and quantity, how quantity affects our decision on the price, and here price here is the price per house. Okay, and so now, so that means, allow me to even write a little further. Price now is indeed understood as a function of lowercase p, a function of x. So it's a function of x here. Okay, and so now you can see further that, and you can start making that connection and that explanation of why, a lot of businessmen, a lot of business professionals, they tend to derive these functions most often in terms of the quantity as the main independent variable right here, because it's convenient, especially when it's cost. Okay, so they want all of these functions to be, in the same variable, so it's easier to work with later on. Okay, so now we are ready to sell our revenue away, to sell our houses away. So now revenue, recall again that revenue is the price per unit of your product multiplied with the quantity. And so straight into this, or directly into this concept, then price has already been found as a linear function, p of x. That's p of x. And then we multiply that with quantity here is the x. And so that means we can multiply x with minus 4,000 x plus 1.8 millions. Okay, and now all of a sudden we realize we have derived for ourselves what's so-called a revenue function, capital R, but as a function dependent on x. So you can see that I carefully wrote down the revenue relationship earlier, but I did not get directly into naming it because, at that point when I was saying earlier, revenue can also be dependent on the price factor as the independent variable. So at that step, when I was just generally introducing the picture, I didn't want to mention that. But now when we're clear that we are deciding things in terms of the quantity, then now our revenue is also a function dependent on the quantity as the main variable here. So now our final revenue here, R of x, is going to be minus 4,000 x squared plus 1.8 millions. That is our successful revenue function. Okay. And so now we have come to our revenue function. So we've had revenue function. Okay. So these are, and as I said in the beginning, from the beginning of this video, it's all about we bringing back the old concepts that we've learned, and we're going to start, and later on in the later steps we are going to put on top of that the new concepts. Okay, so now let's not rush into finding profit, because it's at this point it's clear that anyone eventually is going to have to find profits. But let's see, even we already found what the cost function as a function of x, the pricing function, and from the pricing function we were able to come up with revenue. Let's see what else we can do right here. And so that's why, as I said, everything right now, it comes right out from my mind as, completely on the go, and no plan ahead of time, okay? No plan of what to do. So here, let me quickly swing over to the other board, spending some time to erase it. And so on the other board, now, this thing I want to emphasize, this next thing I'm about to emphasize, directly drawn out from the information we have derived so far. Some schools, some professors, they teach this at a finite math courses, but some schools, some professors, they wait until at the business math course to emphasize this, to teach this. But you see, we already had the cost. But our cost that we listed down earlier, this is more like total cost. It's total cost, all the variable cost together with the fixed cost, total cost. This is to be precise. Okay. Total cost. This is like how much totally that you have to spend, or you can predict how much you can spend based on this modeling function right here. So that's total cost. But now I'm talking about, there's a, right out from, once you have your total cost, you can do this. You can do, from your cost function that you already derived, you can divide specifically by x right here. And we call this, actually, well, the symbol for that, C with a bar. Many textbooks use that symbol. Okay, so I also set myself into using the similar symbol. But what is this? This is, and as I said earlier, at some institution, some school, they teach this at finite math courses for for business. But some schools, they wait until at some math department, some schools, they wait until the business calculus to start mentioning this. But anyhow, and the reason is because some people use it, some people don't. So there's still a controversy out there about how useful this is. I don't really use this that much, but it's good that I mentioned so any of my students will know. So this quantity here is being referred as average cost. Okay, average cost is different with the other cost. This is the total cost right here. The C is the total cost, but average cost, you see how we divide the total cost by X right there? So this is cost per item. On average, okay? Just like we would find an average value. So here we produced X items, okay? And so and we already knew that producing X item cost us this much amount C dollars. Could be C thousand, C millions dollars, whatever. But dividing that by the number of units in our production right there, that's called the average, the cost per item. So this is another way of saying that. This is cost per item. Okay, that's cost per item. Okay, and so in that way, let's quickly derive, because we already had our total cost function. So consequently, right in our particular problem, because we're trying to dig out as much information as we can. And so what is our particular average cost function here? Well, our total cost function was $120,000 times x plus 1.5 million. So now all we do is just take all that c of x function, divide by x. The work is completely algebra. Okay, and so I believe, a lot of time, usually this function is taught at the finite more usually this function is taught at finite math for business major. Okay, but a little bit further algebraically, you can see that this fraction has two terms in the numerator. So algebraically, we can break it into two separate fractions and cancel out the x here. So first term becomes 120,000. Okay, just that, and plus. Now the second term becomes 1.5 million over x. But ladies and gentlemen, this is our average cost function. It gives us, it models in this way how it costs us right here totally. Then on average, each item, if we plan to make x item, then on average each item costs us based on this function, average cost function. Okay, and so that's something else that we learn and we can do to our information, our valuable information that we have found. Okay, so far I've been spending a lot of my time just focused and trying to bring back old concepts that you have learned back in finite math for business. So what can we do what about some new math that we've learned here? So any of these are all functions. Okay, and so now just right here, let me rewrite this. Let me rewrite our revenue function. Minus 4,000 x squared plus 1.8 million. All right, so now here's the calculus part about this. Here's how we can, on top of these that we have found completely based on the material we've learned through our finite math for business. But now the calculus say we can take C prime. C prime is different with C bar that we did earlier. So as I said, C bar could be new, could be old for somebody, but C prime is completely new because it needs calculus to understand. But now our function C of x is 120,000 x plus that's $1.5 million as a constant. So really taking the derivative of this function is simply giving us a 120,000 as a constant. But what is now the meaning of this? This here now, in a different video lesson that I have already delivered, then this formally now formally speaking, we can use C prime of x as this is our marginal cost function, because with this function now it helps us to model the how much cost that we can additionally bring in. How much cost that comes out for us when we additionally produce one more item. And so that's what the C bar is for. And I have not plugged in any value for x, but this is what we can do, with the old concept and connecting with the new concepts here. The derivative is the new concept that we've just learned throughout our half quarter long so far, the calculus concept. Okay, and the revenue function. Well, we already found our revenue function. Then we can also find R prime of x. And once again, for students who have done some derivative work, then finding R prime of x is simple with a function like this. we are going to get minus 8,000 x. And I believe I had a typo here. I skipped that x there. Okay, but so that now is going to give me plus 1.8 millions. Okay, so now r prime of x is in a different video lesson I explained that this is now going to be this is now officially used as our marginal revenue. Okay, how much revenue we can bring to our company, about how much revenue that the packing in real estate company can bring to themselves by making one additional house. Let's say if they first plan 40 houses, and then they want to find out how much revenue they can bring in by selling the 41st house, making one more house and sell it away. Okay, that's what it is. And so marginal revenue, but this is just a general function. That's what we can already do with just the information being so valuable that's introduced in the beginning of our video lesson here. Okay, so that's R prime right there. And so now we can still do further work. So now profit must be revenue minus cost. And so in that way, our profit function can be set up as following. We had our revenue function being minus 4,000 x squared plus 1.8 millions x. Okay, now that's our revenue. Now we are going to subtract. Now I'm running out of line, so allow me to, after that subtraction sign, I'm going to write my cost function in the next line down right here. But cost function here is going to be 120,000 x plus $1.5 million. Okay, and so now again it's just the algebra work that we need to carry through. So P of x here is going to be minus 4,000 x squared, right? And then 1.8 million x minus with 120,000 x right here. Okay, and that gives me plus 1,720,000. Okay. All right, so I have to apologize to viewers, but just now I recognized an error. But this is a perfect example, a perfect proof that I am doing this in front of the camera, in front of anyone, completely live here, no planning ahead. So a calculation error. It was a simple calculation error, but it led to a lot of errors in the amount right here. So let me go back to the other board and correct that. So back to this step when I was deriving the algebra. So I'm sure that feel free to roll back in the video and check back at my steps right here. But this value right here, I made a huge calculation error there, and this was supposedly, this value right here needs to be changed to only 360,000. That's so back in the steps. So the cost function was completely good, but the pricing, the demand equation that I've used was incorrect. And so in that way, it led to such a huge amount of difference like that. And so consequently, that means this term right here in my revenue function, this term is corrected to only 360,000 x. And that consequently must change my R prime right here. And R prime this last term of my R prime. But see, it's still, at least it's still easy to trace it down like that. 360,000. Okay, so minus 8,000x plus 360,000. And so in that way, now back in my other board right there. This value here needs to be changed to, this needs to be 360,000 x. That's for our revenue. Okay, and then we're taking away, so the cost function is still all here. So this value here, I was almost made that error, but all of a sudden something pulled me back that I felt something wasn't right. And so now subtracting out, we're looking at minus 4,000x squared plus, and that would be 140,000 x in the middle term. Okay. Actually, again, to make another mistake, there 240,000, and then minus. All right. So minus 1,500,000, and that is our profits function. That is our final profits function, and so that's how we derived our final profits function. And another concept here that was covered, that was introduced back in your finite business math course right there. Okay, so now with the calculus, now back at your finite math courses, then you have also learned that with a function like this, and particularly it is here in our particular problem, it's a quadratic function. The same with the revenue function. With the revenue function now, after my correction right here, and supposedly my revenue is minus 4,000x squared plus 360,000x. This was a quadratic. And so recall from a concept we have learned back then for in finite math for business, then we can always maximize a quadratic like this, or we can also maximize our profits function, because the quadratic here with a negative leading coefficient is going to be a function that's pointing down, and the same with the revenue function that we're looking at right now. The revenue function, the leading coefficient, the revenue function is a quadratic function, and it has leading coefficient being negative, so the parabolic shape, the parabola, is going to be pointing down. So there were those kind of problems where we find the quantity where we max out, that we can find a maximum revenue, and there was also that problem where we can find the quantity. So that's why it's a good problem for planning. We can find a quantity that makes our profits the most, be at the maximized. But see, in calculus, we will eventually learn even a better technique to get maximum and minimum value of a function. So for that reason, in this particular lecture right here, I am not going to get into using the old algebra to find maximum value of our profits, as well as finding the value that maximize our profits, or the quantity that maximize our revenue. We're not going to do that here, but we're going to wait until a few more lectures where I start formally teach about how we use derivatives to find maximum and minimum value problems. But now right here, after we've found, and we've gone a long way, we really have gone a long way with one piece of information, one page of information, worded information, and we found so much. We found a cost function, and consequently we came out with average cost function, and we also come out with taking the derivative. This is calculus concept, and we came up with marginal cost function, and then we can also find R prime right here by deriving our revenue function, and then R prime consequently came out minus 8,000x plus 360,000. And it's all that, and again, I apologize for the error I made earlier, but it's still easy to undo with those errors like that. So just like that, for our profits, we can also find p prime of x. And p prime of x here, strictly as a mathematical problem, it's It's the derivative of P. Okay, so minus 8,000 x, okay, but plus 240,000, and that's our P prime. But so now let's look at that. Let's look at what it tells us right here. This is going to be the marginal profit function. Marginal profits function. Okay, and marginal profits, okay, function. All right. And so at this point right here, that's all I would like to introduce. We've gone a long way, and we've highlighted all of those concepts that we've done all the way from finite mathematics for business, and now blended on top of that with these concepts we just learned not too long ago, that using derivative, our understanding for calculus. All right.